All right, hello. Today we're going to start with going over a parabola. Now we've talked about parabolas before in class, the equations for them, but what we haven't done is really define them as, you know, how they relate to a conic section, like slicing that cone to get a parabola, or their technical definition in general. Now, last time we talked about circles and how circles are an infinite set of points that are equal distant from a central point. So today we're going to do this small activity to bring us to the definition of a parabola. So what I want you to do is get a piece of paper out, and it can be a piece of paper. It could actually, some people use like wax paper for this, tracing paper, that sort of thing. I just use a regular sheet of paper and put a dot anywhere on it. We don't want to get too far away from the center, but it doesn't have to be at the center. So as we look at this, I put the dot right there, and then I want you to fold a line about a third of the way from the bottom edge there. On this line, you're going to just put a bunch of dots, say like 10 dots going down that line. I've got a few more than 10 here, but it doesn't matter. You don't want to put like a whole bunch because then you'll be pretty busy with this activity. It's just to bring out a few things about a parabola. Now, what I do is I pick the leftmost dot, and I'm going to put it right there on that original dot we drew towards the middle of the page, and I'm going to crease the paper. So you do the same with that, and then we're going to go to each dot and do the same. So you take that dot, put it on the one there towards the middle of the page, and make a crease. So you can pause the video and go through and do all those. I'm going to fast forward the video a little bit here so you don't have to watch me do each dot like that. All right, so there I am putting that last one on. And then once you've done the same, I want you to take back and look at the folds in your paper. Let me bring this up closer to the screen so you can kind of see how we start to form a parabola here with those folds. So the next thing I'm going to do is I'm going to pick one of the lines. Actually, let me just go ahead and trace out this parabola so you can kind of see it a little bit better on the camera. And I'm just tracing along where those folds meet up. You should have the same thing on your paper. So now I'm going to pick one of these points over here on the left and just kind of fold it. It doesn't matter which point, just for this demonstration. Recrease that line, and I'm going to trace it just so you can see the tangent line that forms with the parabola. Just to make it a little bit easier to see which point I picked from, I'm going to circle it right here. And if I were to measure the distance from this point to the parabola, let me draw that line. And from this point on the parabola, inside of it, to that same point, these two distances are equal. And the next part, I tried to show with a flashlight here how they match up. You can hold your piece of paper up to a light source and see it pretty easily. I tried doing this with the light on my phone. It did not work out so well because the camera compensated for that on the exposure. So I'm going to fast forward through that. But this is kind of starting to show exactly what we're dealing with when we're talking about the definition of a parabola. Now, let me remind you of a few things that we've already learned about parabolas. One, we have this line of symmetry that comes down through the center. That's where it's symmetrical, about that line of symmetry there. We know that each parabola has a vertex, and that vertex is right here, and that's on the line of symmetry. So this is our vertex, and this is our line of symmetry. But we also have a few new things that we want to introduce here when we're talking about parabolas. One of them is this point that we put in towards the center of the page there. This is actually what we call the focus. Now the reason why we call it a focus, if you're using a parabola, say in a mirror setting, you have a parabolic mirror, and we talk about this in physics, if we have parallel lines that come in and hit this parabolic mirror, these are lines that are parallel to the axis of symmetry. When they hit that mirror, they actually bounce towards the focus like this. All the lines will come through these light rays and bounce right towards the focus. Or you could say that the mirror is focusing those rays towards that focal point. And so, therefore, it's called the focus. So that's our focus. And then we have this other line that we fold it down here at the bottom of the page that we put all of our dots on. That is called our directrix. And so all of these points, if you were to draw a line from here to the parabola, the shortest distance, and measure it, it should be the same as from that same point to the focus. So if you think about it, this point right here on the parabola is the same distance away from the directrix as it is the focus. And this is where we're going to start tying in our definition of a parabola. So go back to your definition for a circle. We said that a circle is a set of infinite points that are the same distance away from one point called the center. So that's what a circle is. All around this curve right here are an infinite amount of points, and they all have the same distance away from the center. I want you to pause the video and see if you can come up with a similar definition for a parabola based on those vocab words I gave you there. So you have the focus, the directrix, and you've got that same beginning. I'll start you off. A parabola is a set of infinite points that are, finish that off, so I'll let you pause the video and then come back for the answer. So here in green we're given our definition for the parabola. We got a set of infinite points that are equal distant from, it's not going to be just one point because that would give us just a circle again, but it is from one point, a focus, and a line called a directrix. So we'll say that are a set of infinite points that are equal distance from a point. A point, and we'll call that point the focus, and a line called the directrix. So now that we know more of a technical definition of a parabola, and before we actually get into more things with the equations of parabolas, I just want you to take some time and go through 3 or 4 problems where we're investigating some of these equations of a parabolas first. So you can follow along. If you look at my post, I should have this posted so you can print it out, or you can maybe dual screen this so you can watch this part of the video and pause it as you need to as you go through this worksheet. But the first thing I want you to do on this is to look at the equation y equals 1/8 x squared. And I just want you to solve the equation for x squared. And notice the directions say not just for x, but just get x squared term by itself. So if we do that, we're just basically multiplying both sides by 8 here, and we get 8y is equal to x squared. So that takes care of that part. It says, what is the coefficient in front of the y? Well, our coefficient is 8. And it says to draw a horizontal chord from one side of the parabola to the other that has exactly that length there, 8. So if I look at it, that's going to be right here. Notice there are 4 to the left of the y-axis and then 4 units to the right of the y-axis. And so total length of this chord right here is 8. All right. And then it says to draw or plot the vertex. That's right there at the origin, 0, 0. And draw a point on this chord that is also on the axis of symmetry. So here's our axis of symmetry, it's the y-axis, so here's that point on that chord. That's all that equation 2 right here is asking for. Exact same thing. We're going to look at it on a couple different equations just to see if we can start to notice some patterns going on with these parabolas. So I'll do this one with you again. Get the x squared term by itself. We're going to multiply both sides by 4, and we get 4y equals x squared. What's the coefficient in front of the y? Well, it's 4. Draw our horizontal chord here, and this chord, remember, it needs to start and end on the parabola and needs to be the length of that coefficient. So there it is. Plot the vertex. There it is. Draw a point on this chord that's on the axis of symmetry, right here. So stay with me. We're setting up something here so we can see those patterns. Try it again for equation 3 here. So once again, our coefficient's right there in front of the y. It's 2. Now notice this time, when we try to draw a horizontal chord from one end of the parabola to the other, that's exactly 2. We don't see it on our graph. We actually have to come down. It won't be at least an integer. It's got to be right in between these right here. We're going to draw our horizontal line and then put your vertex on it. And then a point right there in the middle of that chord. So it wants you to do this. It wants you to have the distance from the vertex to the chord and the chord length on these equations. So let's go back and look at the first equation. Notice it had 8 was the length of the chord. What's the distance from the vertex to that chord? Well, let's see. This right here was 8, the chord length, and then this distance is 2. So we want to record that, 8 and 2. 8's the chord length, 2 is the distance from the vertex to the chord. Do it for equation 2. Equation 2, length right here of the chord was 4, and then the length right here is 1. So we have 4 and 1. And then lastly, with the equation 3, we had the length of the chord right here is 2, and then this distance right here is, you can't really see it because it's not marked, but it's 1/2. So we have 2 and 1/2. So we can go back and look at these things if we want to, the coefficients, how they, and that's your chord length, how it relates to this distance from the vertex to the chord. So it wants you, it's actually giving you a big hint here. It says divide the chord length by p. So here's our chord length. This column's p. 8 divided by 2 is 4. 4 divided by 1 is 4, and 2 divided by 1/2. Remember, when we divide like that, we keep it, switch it, flip it. So keep it 2, switch to multiplication, flip it, and we get 4 again. So all of these are coming out to be 4. What do you notice about the ratio? What I just said there, it's 4. What do you think, why do you think we plotted a point on the chord that is on the axis of symmetry? Is there anything special about this point? And so you can take a moment to think about it if you want, but since we're on video and not in the classroom, I'm just going to go ahead and give you the answer. This point right here, let's go back and look at that again. As I drew this out, we got our point right there. That's our focus. So we have our vertex here. Our focus is that point right there bisecting that chord. Now, what that allows us to do is to look at this equation, and it helps us figure out how much does the parabola open up. Because notice, if this coefficient, when we solve for the square term, if that coefficient is larger, well, it's going to open up more. And as it gets smaller, see 4, notice our parabola does not open up as much. And then when it gets down here to just a 2 in the front, it gets narrower and narrower as the value of that coefficient goes down. So it's one of those things that if we notice that pattern and we can start to see that, we don't just have to plot points to graph and see if the parabola opens up more or less. We can quickly describe how much it's opening just by that chord there. But it also helps us do a few other things as we get into parabolas. Now, what I want to take you through here is the standard form for the equation of a parabola. So on the left is what we studied in the fall, the vertex form, where we saw h and k, remember, were the vertex of our parabola. And A kind of described how much it opened up, or whether it opened up upwards or downwards. So we're going to switch gears a little bit and start talking about the standard form of the equation here, which is what I've got written on the right. And we kind of come up with that with the equation from the left by subtracting k from both sides. We get y minus k equals a times x minus h squared, and then multiply both sides by 1 over a. And this 1 over a is what we're letting be 4p right here. But before, we really didn't know what the value of p was. What does that mean? And what does 4 times p mean? And so that goes back to these equations here. And ultimately, it goes back to what we were doing over here with this parabola. This distance right here from the directrix to this vertex is actually the value of p. And because the distance from here to a point on the parabola is the same as from that point on the parabola to the focus, this value is also the value of p. Now, what we just discussed with these patterns, if this value right here is p, then this chord right here is 4 times the length of p. So this distance, no matter which parabola you're talking about, is going to be 4 times p. So let's go back and add one more definition here, or one more important spot on our parabolas, and that would be this chord that goes across. So this chord is what we call, it's actually Latin, it's called the latus rectum. And some people think that's kind of funny. They giggle in class, there's a word there. So I'll just refer to it as the LR, all right? And the LR is equal to 4 times the value of P. So once again, review what these things mean, because this is all new stuff. We haven't really talked about this before. P is the distance from the vertex to the focus. And then this bar right here, this chord, the latus rectum, or LR, is 4 times that length. So you give me the P value, this is going to be 4 times the length. Now, another important thing to note is that this distance is P. Well, so is this distance from the vertex to the directrix right here. Its value is also P. Remember, if you were to fold these on that piece of paper, this distance should equal this one when you're talking about the point directly below the vertex there. All of these things come into play when we're looking at these. Like, for instance, if I were to tell you to look at equation 1 and draw the directrix, how would you draw the directrix on that? So remember, we know that the distance from the vertex to the focus, it's length p. In this case, the length is 2. The LR is 4 times the length of 2, or 8. But the directrix, notice, is going to be perpendicular to our line of symmetry, because it can't intersect the parabola. And it's going to be the same distance downward. So this right here is going to be the LR going like this. Perpendicular, or meeting that line of symmetry at a right angle. And the same distance away from the vertex as the focus. Try it on the next one. Where would the directrix be? So once again, here's our vertex. Here's our focus. The vertex is length 1. So that means the directrix must be in the opposite direction of the focus from the vertex, and it has to be perpendicular to the axis of symmetry. Now remember what the directrix, the importance of the directrix. It means if you pick any point on the directrix and draw a line to the parabola, the shortest line you could make to the parabola, it should be the same distance from here to the focus. Now that's horribly drawn. I must have picked the wrong point. Maybe it should be somewhere up here where these two match up more like that. But either way, that's what we're meaning. This distance should be equal to that distance right there. Once again, if we were to draw our directrix here, notice that the focus is only 1/2 of a unit away from the vertex. So the directrix is going to be halfway below the vertex there. So discussing the standard form, our standard form is going to be written like this. X minus h squared equals 4p times y minus k squared. Remember what h and k stand for. It stands in this case for our vertex of the parabola. P here stands for the distance from that point to 2 different spots. One, to the focus. That value is p units away. And then the other is to the directrix in the opposite direction. All right. And then, of course, xy, like any equation we've done this year, xy stands for any point that is on the curve here. So any of those points could be x comma y, and we'll use that sometimes. Now up until this point, we've always talked about parabolas as a function, whether they open upwards or like this one right here, they open up downwards. So this one right here for our standard form would be x, not x minus 2, x minus h squared is equal to 4p times y minus k. And in this case, our p-value is positive. And notice if p is positive, this whole thing right here is positive. And just like when we did vertex form, where when a was positive, it was opening upwards. If p is positive, this thing is opening up towards the positives. Now, for downward, p is going to be negative. So we're going to have x minus h squared equals 4 times p. And our p-value here is going to be negative. And then we got y minus k. Because p is negative, our parabola is opening up downwards. These are for parabolas that open up upwards and downwards. Now, we're in the chapter on conic sections. Now, conic sections are not always and often are not functions. Like a circle. A circle is not a function. It doesn't pass the vertical line test. When we talked about parabolas before, we were discussing parent functions. And that's why we approached everything with the parabola opening up upwards or downwards. But now that we're just talking about conic sections, we can also talk about parabolas that open up sideways, like this. In this case, our equation is going to change a little bit. Notice on parabolas, only one of these is squared, not like circles. And later on, when we talk about ellipses and hyperbolas, both terms will be squared. This guy over here, the y minus k, is raised to the first power. So that's how we can quickly look at one of these things and recognize, hey, I'm dealing with a parabola. Only one of them is squared. So when it's x term squared, it opens up upwards or downwards. And it's the x minus h quantity squared there. Just like we're used to seeing. We're used to seeing that parent function y equals x squared, and we know it opens upwards. But if we were to switch it around and make it the y minus k term squared, then we've got something that's opening up sideways. So notice all I did really is just switch around these two in parentheses from over here. Since p is positive, just like when it opened up towards the positive values on the x squared term, it's going to open up towards the positive terms or to the right when p is positive over here. If it opens up towards the negative terms or points to the negative direction on the x-axis, that's a case when the p-value is going to be negative. And so whenever that p is negative, whether it's horizontal or vertical, it's going to be opening up towards the negatives. When it's positive, we're opening up towards the positives. This is important stuff, so if you didn't get that, go back, rewind this thing a little bit, and check it out. Now, I'm going to take you through some of the problems from our textbook. Not all of them are homeworks, and I'm going to try to avoid doing the homework problems for you, although we will have something come out probably later on that you can get some help with the homework. But I think if you work through these here with me, you might be able to understand this a little bit better than just watching the basics. You can kind of dive into some problems. So this may not be posted on our classroom page, so go ahead and pause the video and try these problems out. We've got equations 13 through 18 here and letters A through F graph. Don't use a graphing calculator. Analyze these equations, see if you can match them up with the correct one. So pause the video, take a few minutes to do that, and then come back and watch the answers. All right, so I'm going to attack these how I would the first time looking at them. I notice that when I have a y squared term and the x squared isn't, or the x term is not squared, only one of them is squared, I'm dealing with the parabola. Now we're in the section on parabolas, so all of these 13 through 18 are going to be parabolas. But just something to kind of point out, because eventually in this chapter I'm going to throw everything at you. Equations of circles, hyperbolas, ellipses, and then parabolas. And so you got to identify which equation is this. And so parabola is the easiest one. If only one of them is squared, it's a parabola. Next thing is to figure out, does it open upwards, downwards, or left and right? So remember what I just said a few minutes ago. If it's y equals x squared, going back to our original function days there, we know it looked something like this. So if the x is the one being squared, it's going to be opening upward. And of course, if p-value is negative, it opens up downward. So over here, this is the y squared term. So it's going to be opening left or right. And so it's in this format right here. Y minus k quantity squared equals 4p times x minus h squared. Now, the only thing about that is, some people have a hard time seeing this and thinking of this, because this looks a lot more complicated than what we got going on in number 13. So we can simplify a few things here by identifying like, hey, my k value must be 0. So it's like y minus 0 squared, which is just y squared. My h value must also be 0. This tells me that the vertex is at 0, 0. All right? So it's either opening up left or right, and the vertex is at 0, 0. Well, that throws out A through D there. Only E and F open up left or right. In fact, they both just open up to the left, and they have vertices that are at the origin. All right, so that's the vertex. The next thing I want to know is, what is the p-value there? Well, p is in front of this right here. In fact, I can just take that -4, that coefficient, -4, let's find somewhere for me to write here, and set it equal to 4p. Because I know in this equation, whatever's in front, if it's in that format, whatever's right here, that's the coefficient of the x term. And so solving for this for p, I get p to be -1. So that tells me a few things. I know that p equals -1. I know that the LR, what must be its length? Well, it must be 4 times that length, or it'd be -4, but if you're talking about the distance or the length, it's going to be absolute value of 4. And so this can automatically start drawing this thing out as we get into graphing these things and not just matching it to be a little bit easier. But I'm going to look at this and say, if I go 1 to the left here, that's my value of p, and draw a line perpendicular to my axis of symmetry, is the value 4? Is that length there 4? And notice this distance right here is 4. If I were to think it was this one and drew my vertical line right here, I can kind of see it's closer to 6 or something like that. So E is actually linked to number 13. All right, number 15. Actually, we can go over here, number 14. Let's do number 14 next. Sometimes they number them left to right, sometimes they go up and down. Number 14 is an x squared, which tells me it opens upwards or downwards. Once again, there's nothing being subtracted from it, so it tells me my vertex is at the origin. And in this case, 4 times p is equal to that coefficient right there, 2. So the p-value is 1/2 when you get p by itself there. Divide both sides by 4, p equals 1/2. Now, since it's positive, it must open upwards. That coefficient's positive. So that kind of just leads me right down to b, but just to check, if I go up 1/2, there's my focus. The LR should be length 2, which it is. And so this right here is number 14. Let's look at number 15. So for number 15, once again, x squared term tells me it opens upwards or downwards, not left or right. The coefficient right here in front of the y is negative. There's nothing being subtracted or added to the x and y values like we got going on in number 17. So that tells me that the vertex is at the origin. You're subtracting 0 from it. So I've got something opening downward, and it's at the origin. It's going to be letter D, but just to show you how the 4p thing works out, 4p must equal that coefficient, -8. So p's value is -2. So from the vertex, we go down 1, 2, and this should be length 8. Notice this is at x equals 4, this is x equals -4. That distance must be 8, which is the value right here of our coefficient. If you take the absolute value for distance. So this is number 15. So number 16, I've got a y squared term. It tells me it opens up left or right. and the coefficient in front of the x is negative. So it tells me it must look like this right here. There's only one that does that, and that's f, but just to check, let 4p equal your coefficient in front of the x, negative 12, p equals negative 3. So from the vertex, we go over 1, 2, 3, and this distance right here, whatever that is, it should equal 12. It's kind of hard to tell because your parabola gets cut off here, but that just kind of verifies, you know, that's going to be number 16 there. It verifies how much it opens up for us. Now, 17 and 18 get a little bit more exciting just because it's not, you know, the vertex is not at the origin. So let's make sure that we cover those. This tells me if I've got x minus h, what must I have put in for h to get x minus 3? H must be positive 3. Same thing right here. The k must be positive 1 because you're going to put it in for y minus k in that equation. So that tells me my h comma k is 3 comma 1. That's where the vertex is. At 3 over 3 up 1, it looks like it's going to be letter choice A there. Just to make sure, the 4p value there is positive. So that tells me that it must be opening up towards the positives, which A does. And if you set 4p equal to 4, you get p equals 1. And so let's see, if you go over 1 right here and draw that perpendicular line, it's going to be a length of 4 right there. The LR equals 4. So that does match up. That's number 17 there. Number 18, first thing, you know, once again, it's a parabola, only one of them squared. Our vertex must be, just take the opposite values there, negative 3. That's the opposite of positive 3. Positive 1. So at negative 3, 1. Boom, right there. I know it's going to be opening up downwards because, for 1, it's the x squared term, so we know it opens upwards or downwards. And it's going to be downwards for sure because our 4p value right here is negative. So if you have 4p equals negative 2, then p must equal negative 1/2. So if you go down 1/2, you're at the focus, and then the LR must be equal to 2. All right, and now we're getting into kind of where the little more difficult problems, I don't know if difficult, they're just different problems that your homework is going to be covering. I put your homework assignment up here at the top, and that's going to be in a maybe by the time you watch this video, I might have changed it. So make sure you check whatever assignment where I'm giving it to you, Google Classroom or whatever, to check your assignment, make sure it's still the same. But I don't want to do your homework for you. What I'm going to do is I post them up here so I don't accidentally do one of your problems for you. I'm going to do the one next to it. Like 19 is on your homework. I'm going to do 20 for you. So that way you get a good examples there to kind of go along with your homework while you're trying these things out. Now there is a difference between 19 and 20. 19 is a parabola that opens up upwards, so that tells me it's going to be the x term is going to be squared there somewhere in the problem when we come up with the equation. 21, it opens up leftward. It's a horizontal opening, so it's going to be the y term that's going to be squared. It's going to follow, not 21, but 20 there. 20 is going to follow that pattern of y minus k quantity squared equals 4p times x minus h squared. No, not squared. Whoops. That doesn't get squared this time. Remember, it's a parabola. So only one of them gets squared. It's the y term because it's opening up left or right. Now, a few other things to take note of here. P's value must be negative because the parabola is opening up towards the negatives. So this p value, whatever it is, must come out to be negative. I know the vertex is at the origin, so I can write it in like this. And what I don't know is what is p's value. So I need to fill out some of these variables. Actually, before I start this, we don't need to make p negative. It will show up naturally in the equation if it opens up to the left, as we're going to see. That'll mess us up if we put p in as negative. Just know that it should come out to be negative or we did something wrong. And the reason why it's coming out negative, why we know that, is because it's opening to the left. So this point right here is important. They tell us that negative 2, 6 is a point on the parabola. And remember, that's what x and y stand for. any point on the parabola. So I'm going to plug those in so I can find the value of p. So x is -2 and y's value is 6. Let's solve for the value of p here. -2 times 4 is -8. So we get -8p equals 6. Divide both sides by -8 and I get 6 over -8 equals p, or -3/4 equals the value of p. So that just told me that I'm going to go over -3/4 to find the focus if I want to find the focus. And then I can find the LR just by multiplying this by 4. The LR is equal to 3. Either way, let's go back and see what the directions said. Find the standard form of the equation, and that's all we got to find. So let's do that. Here's our standard form written out like that. I need to put in the origin, and I need to put in p, and I'm done. Well, the origin's at 0, 0, so I get y squared equals, let's see here, 4 times -3/4 gives me just -3, and just x right here. There's your equation. Because h and k were both 0, it just kind of simplifies to something super simple looking, doesn't it? You try the same for number 19 on your homework. All right. Next one was number 21. That's what you got to do for homework. So I'm going to go over 22 with you to see how you do with that. So what I like to do is look at these graphically while we try to work these problems out. If you get a grasp of what's going on in the graph, it makes things so much easier. If you know those new vocab terms I'm throwing out at you, like focus, directrix, LR, the equation kind of unfolds a lot faster for you. So 22 says our focus is at -3/2, comma 0. So at -3/2, so if this is, it's not the best because you've got to kind of, so your -3/2 can be -1.5, 0. There's where your focus is. The directions say that the vertex is at the origin. So right here is my vertex. So with that being the case, our parabola must open up like this. Because remember, the focus has to be on the inside of the parabola. And since it tells me it's opening up to the left, it's kind of like number 20 that we just did. I know it's going to be something like that where the p-value is negative and it's the y term that's going to be squared. There's other things I can come up with. I know that the directrix must be at +3/2. It must be going, if p's value is -3/2, then I go 3/2 this way, or 1.5 this way, and boom, there's my directrix. I can also figure out my LR if I wanted to. LR, remember, is 4 times p. So if p equals -3/2, then 4p, so here 4 times p must equal -6. So this distance right here must be a +6. We're talking about distance, absolute value. So it's above 3 and below 3 right there, a total of 6. So all of those things I can quickly figure out just by knowing where the vertex and where the focus is. But they want to know what is the equation of all this. So we're going to go back to that whole y minus k squared equals 4p times x minus h squared. Remember, our y and our k just simplified to this because the origin is my hk, 0, 0. It won't be in the future, but these kind of start you off kind of simple. I just figured out 4p right here. It's -6. And so there's my equation for that parabola. See how much easier it is knowing what those terms are? If you're like, no, it doesn't, I don't know what those terms are, back this video up and watch it again. Or, Google it. Look up some things about what is the latus rectum on a parabola, what is the vertex, what is the focus, what is the directrix. Learn those vocab terms. And that makes this stuff so much easier when you start looking up the equation of a parabola. All right, let's try out, let's see, you've got 21 for homework, 27 for homework. Let's do one where they give us the directrix. So 28 is what we're going to do, 27 is for homework. So number 28 says your directrix is at x equals 3, and we're still following these directions where the vertex is at the origin. Now let's explain something on this directrix. Notice it's the equation of a line, x equals 3. If I go back and look at this equation for number 22 that we just did, this directrix right here would be x equals positive 3 over 2. Remember how that works with our vertical lines. It's x equals a number, boom, vertical line at that number. So the directrix is not a point like the vertex or the focus. It's a line. It's the equation of a line. Remember when we did that activity at the beginning of this video, we put dots going all the way down that line, and from there we had to fold those over. That was our directrix. So it is a line. But anyway, they're giving us the line on number 28 of x equals 3. The vertex is at the origin. Pause the video, try it out, and then come back here. All right, so the directrix is at x equals 3. And that's beautiful. I got a computer here, and I still draw these graphs by hand. But hey, I want to have the same advantage as you have here, right? So x equals 3. This isn't the best spacing I've ever done on a graph, but boom, there's my directrix, x equals 3. Because the directrix is vertical, automatically telling me that the line of symmetry must be horizontal because they're perpendicular to one another. That tells me this thing either opens up to the right or it opens up to the left. It's going to be one of those y-squared equations. So anyway, we know that the origin is the vertex per the instructions there. And so the p-value here is this distance, or 3. I know it's horribly spaced, but it's 3. And so p is equal to 3. That means 4p equals 12. Now, does it open to the left or to the right? Consider something here. If it opened up to the right like this, what looks odd about that? Well, if you go back to our folding activity, look at your folded parabola there. Where was the directrix? Was the directrix going through your parabola? No, it wasn't. It was over here on the other side. So the focus, which is, well, it's not going to, it would have to be somewhere in here, would be on the same side of the vertex as the directrix, which doesn't make any sense with what we know about parabolas. So this thing cannot open up from, or going to the right. It must open up in the other direction, going to the left. So that means our parabola opens up like this. Now, if I wanted to find the focus, because we will have to find that later, it didn't ask me in the directions. If I wanted to find the focus, I know that the directrix is 3 to the right, so the focus must be 1, 2, 3 to the left. Right there's the focus, and the parabola must be 12, which, if I was asking you to graph this on a quiz like I will later on, this thing better open up like it's opening up for an LR of 12. 1, 2, 3, 4, 5, 6 way up here, and then 1, 2, 3, 4, 5, 6 way down here. So it looks closer to this shape right there. So you can kind of see how the LR helps us graph that later on when paired with the focus. Either way, what's our equation going to be? I know it's going to be a y-squared term. It's centered at the origin, so I don't have to worry about minusing or subtracting or minusing or adding anything to the y. My 4p is 12. It's opening up to the left, so I need to make that 12 there negative. And then it's going to be just an x right there. All right, so we got 33 on your homework. This is telling us to find the vertex, focus, and directrix of the parabola and sketch its graph. So we got a lot more going on this one. Slowly getting a little bit more difficult for you. I'm going to cover 34 and then let you try 31 for homework. So for 34, what I notice is that our p-value right here, actually it's not going to be our p-value. We want to get the x squared term by itself, don't we? So let's do that first. So divide both sides by -2, or you can say multiply both sides by 1/2. Multiply both sides by -1/2. We get -1/2 y equals x squared. And so this tells me this thing is going to be opening up downward. Why? Because it's an x squared term, and this coefficient right here is negative. Now remember, that coefficient is the same thing as 4 times p. So that means 4p equals -1/2. solve for p. You get p equals negative 1/8. So if I'm sketching the graph, here's my graph. I know it's got to be centered at the origin because there's nothing going on like number 42 here. We know that the k value is 1, the h value is negative 1/2. None of that's going on. It's 0 and 0 there. It's at the origin. All right. So you should have, boom, origin like that. And then the p value is negative 1/8. That means if we come down to wherever negative 1/8 is on our graph, there's the p value, or the focus, where the focus is. And then up here at positive 1/8, if we go this same distance in the opposite direction, we're going to get our directrix. Now, it wants to know all of those things about it. Let's move these directions over a little bit. It says find the vertex, the focus, the directrix of the parabola, and sketch it. And so I'm going to add a little bit more to these directions. I like to call it the anatomy of a parabola. Let's go and write down what they got. Find the vertex, find the focus, find the directrix. And let's go ahead and add the LR on there as well. Like, what is the length of the LR? And then make sure we include that in our sketch if we're sketching this thing out. So our vertex is at the origin. So that's going to be a point. So it needs to have an ordered pair, x and y, 0, 0. Our focus is also a point. It's right here. Notice the x value is still 0, 0. This is my xy axis right here. It's still at 0, 0, the x value is, but the y value isn't. It's down negative 1/8. That's an 8 there if you can't see, or a negative 1/8. The directrix, remember, is not a point. It's that line right here. And so it's a horizontal line, so it's going to have the equation y equals, and it's at positive 1/8. Because remember, this distance, let's highlight this in red, this distance should be the same as this distance right here. So what is the LR? LR is 4 times your p value. P in this case is equal to negative 1/8. We figured that out right here. Or you could just say, hey, I know 4p is negative 1/2, so the LR, its length is 1/2 there. So whatever this distance is right here, if we were to graph this out a little bit better on graph paper, that would be 1/2. I didn't graph this one on graph paper just because it's all like fractions, so it'd be kind of, we'd have to rescale it, which wouldn't be too bad, but I like to have a little room to draw when I'm doing the video on the computer here. So you're going to do the same thing for number 33, except for it to be actually hopefully a little bit easier for you. If you multiply both sides by 2, you get 2y equals x squared, and now you're at least got a whole number in there instead of a fraction like we did right there. Okay, so that is an example kind of like number 33 for you. 35, kind of the same thing, so I'll let you do that. It's just going to open up left or right for you there. It's because it's the y squared term. 39, let's do one like 39. Let's do number 40, so that way you kind of see one that's not having a vertex there at the origin. I'm going to leave all these things right here that we need to know for the parabola, and then let's sketch out the rest. So let's see, for number 40, just looking at number 40, I'm just going to box this in so we can kind of be reminded which equation we're working on right now as we do this. I know that the vertex must be at opposite values here at -5 and +1. There's my vertex. I know that it's going to be opening up left or right because it's the y term that's squared. So I'm just going to get that y squared term by itself. Y minus 1 quantity squared must equal -x plus 5. All I did was just subtract this parentheses from both sides. That way it could look kind of like what we were seeing before. And I can see that the 4p value equals -1, that coefficient that's in front of the non-squared term. And so this tells me LR is going to be 1 because it's a distance. It's going to be just the absolute value there. The directrix, we'll come back to the directrix. Let's just find the value of p first. P must equal -1/4. Since p is negative, I know, and this thing is a y squared term, I know it's going to be opening up to the left like that. So let's start to sketch this thing out, and I think these other two will fill themselves out. So here's our graph, and I know this thing's going to be at 1, 2, 3, 4, 5, positive 1 there. That's where our vertex is, and it is opening up to the left. And so we're going to go to the left 1/4. And that's where our focus is, right there. Then we're going to go to the right 1/4. And this must be where our directrix is. And then 4p equals 1, so you go 1/2 above and 1/2 below, and that's what your parabola is going to be opening up like. Whatever, if this were on a piece of graph paper, you could see a little bit more accurately there. So all we need to do is figure out the ordered pair of that focus and the equation of this line right here. So I'm focused here on my x value, and that's going to be -5. And so if I go 1/4 to the right of that, that's like saying -5 plus 1/4, I get -4 3/4. That's 1/4 of the distance to the right from -5. So this equation right here is x equals -4 3/4. That's my directrix. Now if I go 1/4 to the left, that's like saying -5 minus 1/4. I'm at -5 1/4. That's going to the left just 1/4. So my focus is at -5 1/4. comma 1. Remember, it's still a point, so we got to put that in there. So as you do these, make sure vertex and focus, those are points. They should have an x, y ordered pair there. The directrix is a line. It should have x equals if it's vertical, y equals if it's horizontal. The LR is a distance. It should be a positive value there. That's that chord that we drew on those first 3 examples of this video. Now, this video is getting, I kind of explain things a little bit probably in more depth than I need to sometimes. The video is getting kind of long. We're kind of approaching that 1-hour mark. 47 and 48 on your homework. To kind of give you a hint on how to do that, you're going to be, just like we did with circles, you're going to be grouping these terms together. So like number 47, group the x terms, group the y terms. You might have to do a little bit of factoring. You might have to do some completing of the square. Don't stress out over 47, 48 too much. I'll show you some examples later on how to do those, as well as giving you the answers to them. But I think if you've gotten this far in the video, you've taken in quite a bit already. We'll cover completing the square in a separate video on using it towards parabola, so we can do a whole bunch of problems and not just kind of throw on 47, 48 at the end of this lesson. Congratulations if you've made this all in one sitting. It's 53 minutes on the video, but if you've been pausing like you should, you've probably been here for an hour and a half to 2 hours. Hopefully you're kind of breaking it up and not trying to cram all this in. And hopefully it's helped you out a lot after sitting through it for so long. I want you to just want to thank you for working hard, and keep chugging away at this. Let me know if you have any questions, and thanks for working so hard.